All right, I'm sure you're still excited about the flossing example here, but we are now looking at binomial distributions, example 4, part D. All right, once again, we have surveyed 15 people, and we're interested in the number of them that floss every day. So our variable x is how many of the 15 floss every day, which could be anywhere from 0 to 15. All right, and again, it's just a matter of identifying those numbers that satisfy the question. So, what's the probability that the number of people who floss every day, and it says fewer than 14. All right, so let's come over here and look at that. Fewer than 14, here's 14. Which of these numbers are fewer than 14? Here's my question. Would that include the 14? No, I don't think it would. You are exactly right. Mr. Salad Fork is extremely proud of you guys, and I appreciate you interacting like this. Fewer than 14 would be all the numbers from 13 all the way down to 0. So what math symbol would indicate fewer than 14? How about less than? Yes! Yes! Strictly less than 14. That is exactly right. Thank you so much. Mr. Salad Bowl is really, really appreciative of you guys. And I miss you so much, but I appreciate you still interacting like this, at least in my head. All right, so fewer than 14. Now let's look at it. Here's the question that was given to us. Fewer than 14. Isn't that all the numbers from 13 all the way down to 0? Math party, could you set up the probabilities for every number from 13 all the way down to 0 and add them up? Yes, you could do that. If you had enough time, and maybe you do. Maybe you're looking for things to do now, and you can go, party! I'm going to set up those probabilities for all those numbers from 13 all the way down to 0. Love it. Do it. Here's what I love even more, though. Wouldn't the probabilities for 14 and 15 be easier? And let's always remember that if you have 15 trials of anything, shooting a basketball, asking people if they floss, can't you have anywhere from 0 to 15 successes? And wouldn't the probabilities of all those numbers always have to add up to 1? I want to remind you that the number 1 is the decimal equivalent to 100%. How about we take 1 minus these two, and it would equal that? Good idea. All right. 1 minus, and let's set up the probabilities for these two, 14 and 15. Let's start with 14. We've surveyed 15 people. We can choose any 14 of them to floss every day. Floss, which has a probability of 59% to the 14th power, which means not flossing, there'd be 1. 14 people floss, 1 does not. There's that one. Check, please. All right, plus, how about 15? We surveyed 15 people. Choose any 15 to floss. Floss 15. And if 15 of those people floss, how many of them do not? 0! Right on. And that would be the setup for this. And then you'll calculate that. And then keep in mind, since this total is the complement of the question that they gave us, we'll have to take it away from 1. I do not want it to be where you flip a coin to decide when to do the 1 minus. Look at the problem, think about it, and use logic. That's the best thing I can say. So, I know that sounds snotty, but that's what this is. It's critical thinking, okay? So anyway, you're not watching to get to a rant from the old man, but anyway, that ends up total, when it's all said and done, 0.9958256. There you go. So there would be part D. We'll come back, we'll do one more floss example, part E, and then we'll get on with our lives. Thank you.